Hello and welcome. My name is Bob Tickelman. I'm a Microsoft technical trainer, and I want to welcome you to this edition of What You Want to Know When You Want to Know It. Today we're going to be looking at designing Microsoft Azure infrastructure architecture as part of the AZ-305 course. We're going to be looking specifically at unstructured data. Now, there are three types of data we typically look at: unstructured, this lesson, and we're going to take a look at lightly structured or non-SQL data, as well as SQL or schema-based data. That's going to be covered in a later module. So those two topics of non-SQL and SQL data is in a different module. We'll look specifically at unstructured data. And we'll go in and take a look at the different series of data that's available to us and how the unstructured component falls into this thing called a storage account. So we'll introduce you to the heart of your storage journey at a storage account. We'll take a look at the different types of redundancy that it provides to us that is much above what you could support on premises using that traditional storage area network or any of the various types of RAID that's available to you. So we'll look at a range of up to 6 different types of redundancies, from locally redundant, zone redundant, and geo-redundant storages that we have available to us. We'll then take a look at 2 major categories of that unstructured data. Now, the same files could be stored there, whether they be Word documents, XLS documents, JPEGs, MP3s. They could either be stored as a blob storage, what I'll refer to as modern storage capabilities, or that traditional backwards compatibility to Azure file shares. That's going to be accessed over an SMB or server message block access. And it supports that typical UNC or Universal Naming Convention mapping. So we have those 2 different types in the same storage account. We'll then take a look at a feature called disk solutions that you typically use for building your own disk infrastructure, especially if you want to attach them to a virtual machine. If any of you are familiar with the VHD or the virtual hard drives that you associate with your virtual machine, we'll talk and take a look at those different disk solutions. And then we have a whole section of the various types of security that's available to you. You know, all data in Azure is encrypted at rest, and so we'll take a look at that level of encryption. And then we'll take a look at, whether it be blobs or Azure file shares, how do we lock that resource down using something like RBAC or the role-based access control that is going to require a user to authenticate first to be they access those resources? Or is it going to be accessing the information with a thing called a SAS or a shared access token? So all that will make sense after we get into that lesson. So enough for the introduction. Let's get into the content. When you take a look at the wide variety of data that exists, they fall into 3 major categories. And we're going to be focusing across a number of lessons on the unstructured data that are available for you. I'm going to start the conversation there. Unstructured data follows no specific pattern. Your hard drive that you have on your local computer is probably that unstructured data. There's a plethora of file types. You've got JPEGs, you've got MP3s, you've got some EXEs, DLLs. There's hundreds of different file types that all follow different formats of the data that exists either within that file itself. So what we have is this unstructured data, usually large volumes. Now, there's some pros and cons of that. It allows for a large variety of files to be stored. It allows for us to be able to go to a single location to find all that information. But trying to find it other than maybe just by name, it's not categorized data. It doesn't fall into a standard format. So being able to search it very highly efficiently is probably not the best way. So we're going to take a look at a number of ways to be able to store this unstructured data. The 2 other types, called semi-structured, sometimes called NoSQL, is a type of lightly formed structured data. This is going to be in products that we'll show you in Azure called Azure Tables, sometimes referred to as a name value pair. Now, while an Excel XLS file by itself is an unstructured data file because it's going to exist on your hard drive like other data files, the data inside of an Excel file is a good representation of lightly structured data inside of the file. It has a set of rows and columns in what are referred to as name value pairs. The column header has all of these kind of categories below it in rows and columns. And so there's a light structure to that data. Now, it can be whatever structure you want. So that's where we call it semi-structured or NoSQL or schemaless. There's a wide variety of other data types that fit in this, and we take a look at JSON documents. So there's a wide variety of data that falls into this category of semi-structured. Moving off to the far left-hand side, we get into highly structured data, sometimes referred to as schema-based or SQL. This is highly relational database information, and it's potentially spread across multiple tables in a single database. And there is relational information that exists between them. And so you have a customers table possibly that has all the information about a customer. And it has their first name, their last name, their location, their contact information, and maybe their customer number. It follows this thing called a schema. And it says first names must be alphanumeric to this many characters. And it defines the attributes of the data in that table. You may have a products table that has all the details about the products. And you may have an orders table that has all the information about the orders. And so through this relationship, on order number 1 is for customer 27, and it's for product 23. So that's the information that exists in that table. But how do I know what product 23 is? And it's through querying that information that I can now look up or relate this information in the table to say product 23 is actually X number of these products that are defined on that table. So different types of data that follow schemas, but we're going to take a look at the various types of unstructured data and how we can store them. Today, we're going to be looking specifically at Azure architecture and looking and focusing on data and specifically Azure storage accounts. Let's get into it. When we look at the different types of data that are out there, Microsoft provides a wide variety of ways to store that different types of data in highly tuned sets of environments specifically designed for that type of data. In the unstructured data type, which is really where the large volume of most people's data falls into, we have a variety of storage types that are available to store that unstructured data. One of the most common ways is to use a thing called a storage account. A storage account, I want you to think of as this thing called a regionally based unit of replication. And what I might mean by that is I'm just going to go to a whiteboard for a few minutes and talk about what that means. Within Azure, it is a multi-regioned environment, and we currently have over 65 regions around the world. What you're looking at in this picture is US East, which is our biggest region that we have. And it's showing you the size and scope of that region of US East. And in the upper right-hand corner, you're actually seeing what it looked like as of 2014. And the lower portion of that in 2017, only 3 years later, we added a significant amount, and it's grown even since then. But that's just giving you an example of a region. And inside of a region, we have more than one data center. And so each one of those white boxes ranging from, some relatively large ones in the upper right-hand corner to some very small ones that are stacked on top of each other. These are the different generational iterations we've looked at over the years. And you're seeing the massive data centers, what are called our Gen 6 data centers, in the lower portion in the center that were deployed in 2017. Inside of each of those data centers is a set of what you might see as racks of servers. We call them scale units, and I'm going to be referring to those as we go through here. But someplace in one of these regions, we store your data. By default, all data in Azure is stored a minimum of 3 times. And what I mean by that is, I'm going to scroll down here. Most people interact with Azure through a thing called the ARM layer, or the Azure Resource Manager. If I were to write a file in here, I'm going to call it bob.doc. It gets written through the ARM layer, and you can see I can interact with the portal. I can work with templates, PowerShell, REST APIs. I can do it programmatically. But you're going to connect it to a thing called resource providers. We don't talk a lot about this with customers. I mentioned in one of our other classes when we talked about subscription and activating resource providers. But I'm going to connect to a thing called a storage resource provider. And it does some magic for me. What it does, it takes bob.doc, and it doesn't create, some of you might be familiar with the term called RAID, or redundant array of inexpensive or independent disks. It doesn't break the file up. It actually creates 3 copies of that file. And it spreads it across 3 different locations. And we're going to talk more about this as we go through these different sessions. Those 3 copies could be LRS, or locally redundant storage. in a specific region in a specific data center. So LRS, or locally redundant storage, is going to create 3 copies in a specific region, in a specific data center. And this is why we talk about a storage account being a regionally based unit of replication. How does it replicate this data? I can have ZRS, or zone redundant storage, because maybe I want that data spread across 3 data centers in the region and not just one, because that way if one data center fails, I've got some redundancy. Maybe I want that data spread across multiple regions, and we have all of these capabilities, but we'll go into those in a bit more information in a bit. But what it means also, I want to stress, is a term called synchronously written. So I've got this bob.doc, and if I make a change to bob.doc, that change is synchronously written simultaneously and instantaneously across all 3 copies. So again, don't think of them as a backup. It is just a way to make it highly available. So that way, if one of these files becomes corrupted or it damages the hardware, you're still going to have 2 copies of it highly available to you. So the key concept, all data in Azure is going to be stored a minimum of 3 times. And we're going to take a look at how we store that as we go back into the storage accounts, and we can configure the unit of replication that goes along with the storage account. You'll see this as we get into the demonstration. We also get to be able to pick on that storage account, not only the region that it's deployed to, the type of replication it's going to have, we can actually pick the format and the data that's going to be stored in it, as well as the type of hard drives that are going to support this. You're seeing on the chart, we have what is called blob storage. And this is used to support different file types. You're seeing the list there of blobs, or binary large objects. It's used to be able to store data lake queries, tables as Azure files. So we can have all of those different file types in what's called a Gen V2, a standard generation V2, and that's the default that we recommend people use. We also have other premium versions, and I'll show this more when we get into the demonstration, that says I need some more highly available data because the underlying drive infrastructure for Gen V2 might only get me something like maybe 50 or 60,000 IOPS from a disk performance. And maybe I'm using HDDs or hard drives. I may be using standard SSDs or premium SSDs. We get to pick all of those features. As I get into those final 3, the premium block blobs, premium file shares, and premium page blobs, I now get into a limited number of replications because it's going to put stuff in a single data center, but I get much faster disk throughput options where I can get up to what's called ultra disks going at 160,000 IOPS. So all of this will be demonstrated. And if you come back to the materials that make more sense there, but you're basically going to create a thing called a storage account that is that regionally based unit of replication and performance that you'll be able to configure. Some of the considerations when you build it, as I said, it's a location. You're going to want to build storage accounts based on the region. So you have to go, if you want one on US West and one in Europe, you'd have to create 2 different regions, 2 different storage accounts. If you needed them to have different units of replication, they would have to be 2 different storage accounts, even if they're in the same region. And that gets into that compliance feature. If I've got data that needs to be domiciled is the word. So from maybe, for example, I do some work in Canada, and if we're doing it for the Canadian government, they have a legal requirement that the data maintained by its sovereign citizens does not leave the Canadian data center. So we have to store that data in Canadian data center. Very similar to a lot of the European countries and in the United States. So information collected on behalf of its sovereign citizens must stay within specific regions. You take a look at costs, and we mentioned some of these, the different performances that go along with it. And I'll show you in the demonstration how we can impact costs by using replication, that top right-hand option you're dealing with. Today, we're going to be looking at Azure architecture and looking at data redundancy types and how they work and how they fit into your architecture. So let's get into it. We've talked about an Azure storage account being a way to create a regionally based unit of replication. A storage account is a way for you to define a series of attributes of the type of replication, the region that it's going to be used in, as well as a series of characteristics of the type of files that might be stored in that storage account. There's a wide variety of unstructured data that we have. And in fact, you get into some forms of even lightly structured data because a storage account can have tables and queues in them as well. We'll do some of this and point it out in the demonstration at the end. But we want to take a look at this highly available data and what it means to us from a design perspective. We have a variety of ways to store this information. In other modules, I've showed you what an Azure region looks like. And we used US East as an example with the 30 plus data centers that make up that region and the vast amounts of hardware that's available inside of it. In this example, we're going to refer to that as our primary region. Microsoft currently has over 65 regions around the world. And because of data domicile rules and a whole bunch of other things that go along with this, Microsoft, in many cases, builds what are called region pairs. In the case of US East, it is paired with US West. We put this hundreds of miles away to separate them from natural disasters so that if something happens on the East Coast of the United States, the chances of it impacting also something on the West Coast is highly unlikely. We also have, in the United States, 3 different power grids. So while US East is paired with US West, US East 2 is paired with US Central. So that we have, in the United States, 3 different power grids. And so we don't have any one data center or one deployment in a region that is potentially subject to only even 2 data center or 2 power grids failing. So we do this very logically for you to manage that infrastructure. So in here, I'm going to use my example of a primary region and secondary region. I'm going to go off to a whiteboard and actually draw some of these out, so hopefully it makes a bit more sense, and then we'll come back to the slides. What I've got on the slide for you is an example of a data center within a single region. Inside of that data center, we call them scale units, and I've drawn 3 of them here. They look like racks, and they kind of all intents and purposes are. Our racks have what are called fault domains. And you're seeing on the one on the left, at the very bottom, there are a dotted line. There's actually things called PDUs or power distribution units. There's 2 of them so that every node that is in this rack is redundantly connected to at least 2 different sets of power that have 2 different sets of power backup and generators and all that stuff. So we have highly redundant power to this scale unit. At the top, we have 2 TORs that also have network connections. So every node that is in this scale unit is redundantly connected to the backbone of that data center that is redundantly connected to the backbone of Azure itself. So this becomes what is called a fault domain. In a previous module, and in here, I'm going to talk about any data that we write. So if I have a user that is working on a file and they have this bob.doc file, it is written a minimum of 3 times. So in this case, that file is going to be written 3 times. Now imagine if it put that 3 copies, onto 3 different nodes within the same scale unit. They would be in the same fault domain. So if I had a failure and for some reason that scale unit went down, I would lose access to the 3 copies. What Microsoft does is we spread the 3 copies across 3 different fault domains within the same data center. So what we have now is 3 copies, and the term is called synchronously written. So now we have our 3 copies written at the same time across 3 different fault domains in the same data center in the same region. And when I say synchronously written, that means any change that is made at the originating document is instantaneously written across all 3 copies. That is LRS, or locally redundant storage. Now, I mentioned that we have many data centers in a region, and I'm going to expand this out to cover the various types. So I'm going to draw a green file here. I'm going to use green file as LRS. We saw that LRS writes 3 copies of that file against 3 copies in the same data center in the same region, but across 3 different fault domains. Well, that's great, but what happens if the data center fails? I would lose access to that information. What we now have is a thing called ZRS. I'm going to draw this as a blue file. And so ZRS takes those 3 copies, and this time it writes it across 3 different data centers, but within the same region, because they're in the same storage account. Going back to a storage account is redundant copies within the same region. This way I can lose an entire data center, but now I've got extra copies in other data centers. Now, anytime I give you something, I take something away, and there's some small performance hit. It's sub 2 milliseconds is what the communication is, but it's slightly, it's highly available, but it's slightly less performance. And you'll see this as we get into the example of the other performance drives, and I showed you in those 3 premium options. In this model, we also have redundant copies that we can copy to other data centers. I'm going to draw a brown file in here. I'm going to call this GRS, or globally redundant storage. What this does, much like LRS, it writes 3 copies into the same data center. And they're synchronously written. And then what it does is it copies one file of that version of that file to another data center in another region, in this case, the region pair. In my example, we talked about US East. This case, we had 3 copies, would be in US West. Now, there is a delta time difference, and the SLA is, I think, 15 minutes, that says if I make an originating write to this file, they are synchronously done to all 3 copies in here, and maybe a little while later, so up to 15 minutes, it eventually works its way through the network, and it eventually will make its way over to that regionally redundant copy. So these are some of the examples that they have. I have a version of GRS that goes to RA GRS, or read access geo-redundant, which makes this other copy here, it makes it read accessible, but know that you want to make sure that you're not reading file that is important. If it's changing frequently, it may be out of date on the second copy that you're working with. So there's all sorts of reasons behind this. I also have a version of globally redundant storage that is there for zone redundancy. There's GZRS, so it makes the primary copies 3 copies across 3 different zones, and then it does the 3 copies in the other regions. So those are just maybe some examples that hopefully are a bit more easy to understand when it talks about these locally redundant, geo-redundant, read access geo-redundant, but all these different replication types that you're working with that are available for you for redundancy. Today we're focusing in on Azure architecture, and now we're going to be looking at blob storage and some of the performance tiers that we can use in the overall configuration of the storage account. Let's jump into this. Previously, we talked about a storage account having a unit of replication within a region. Within a storage account, you can define the default values of the blob storage types that are going to be in the things called the containers, if you remember that module. So within a blob storage account, I can have multiple containers, and I can set a default value of how I want that information stored. There's 4 data types that we can, or 4 categories of classification: hot, cold, cool, and archive. Across those 4 data types, we can now get different performances, and there's a pro and con. As a hot tier level, I'm going to have a higher unit cost to store data because you only pay for what you use, and you pay a small amount per transaction to read or write. And I'm going to do a demonstration of this in just a minute. So what I have is higher storage costs, but I have lower access charges. If I have files that are accessed infrequently, but I still want them nearly available to me all the time, I can then move them to maybe a cold or cool tier. And you'll see some numbers in there, and I'll explain that in just a minute. It's going to be cheaper to store them, but it's going to cost me more to access them. So you got to be very careful about understanding how data is used, how often it's being accessed, and what the value is to make it available to me. And we'll show you a feature called lifecycle management that actually can move files around based around this data classification. So what I want to do is go in and show you some of the hard numbers that go along with this, because people think that I've heard the general statement, oh, hot storage is more expensive than cool storage. Well, maybe not, because if the files are accessed on a regular basis, it could actually cost you more to keep it stored in cool or cold storage than in hot. Even though it costs you more to store it in hot, the data access charges are less. And I'll show you an example of what that means right now. I've brought up a thing called the Storage Azure Calculator, where I'm going to be able to come in, and you can do this at any time you want. So there's a pricing calculator, and I've added the storage account features to be able to come in and take a look at this. I'm going to come in and say in US East, I want block blob storage. It's a standard performance. It's a Gen V2. These are all topics that we've covered in other modules. If you're not familiar, you can go watch those modules. It's hierarchical namespace, and it's in hot storage, and it's LRS. And these are the different types of storage that are available for us. The amount of storage is 1 terabyte. And I'm going to pick, we've got different discount levels. I'm just going to keep a consistent level. So don't worry about the dollar amount per se. I'm just going to keep it consistent across all of my examples. But there's some significant cost savings depending on who you are, if you've got a reservation, if you've got a close relationship with Microsoft as a thing called an enterprise agreement customer. There's all sorts of different discount levels. But just the raw storage of 1 terabyte in this configuration is $21. But then you take a look at the operational access. And so operations for reads and writes, and you'll see that the cost here is per 10,000, so that's 100,000 write operations. You can see that is 6.5 cents for that many write operations for 65 cents in total. I've got read operations. So the total cost of this storage is $52 at the end of a monthly billing period. Now watch what happens. I'm going to keep a lot of these numbers exactly the same. I'm going to switch this from hot to cold. You'll see that the same amount of storage is significantly cheaper. It's not $15 to store it. It's only $2.37 because the $3 instead of 15, if I pick up the right one. But you're now seeing the data access charges have gone from 6.5 cents to 23 cents per 100,000 operations. And so if you were accessing this information on a regular basis, just as actively as you were in the hot tier, you can see that this potentially could cost me as much, if not more, than a hot tier. So be very careful with that just assuming that cool is cheaper than hot, you really want to take a look at how often those files are being accessed. So storage tiers, a very good way to be able to cost optimize your storage of data by trying to take advantage of cheaper storage if it's not used, but you still want it accessible. Now, I do want to make a call out on that standard archive. Archival storage is super cheap, but it is offline storage. All hot, cool, and cold are nearly instantaneous. Your customers will probably never know it if they're accessing it as a file. Now, where this performance really comes in is if you're storing that information from an application perspective in use. But as an archive storage, it is offline, and you need to recall that file from archive storage. And the SLA is it could be up to 15 hours. Now, you can pay for what's called expedited rehydration, which will bring that file back in with under an hour. But be careful. While archive storage makes the file look like it's there, it may not be accessible. And I don't know many people that click on a file and will wait 15 hours for that little wheel to spin to have it come back into hydration so it's available for you. So storage tier is a great way to be able to architect a solution to cost optimize the storage you're working with, especially as you're really dealing with volumes of data. You can really get some cost savings by looking at the storage tiers. In addition to the storage tier capability, we have what are called immutable storage policies, and this is done on a per container basis. So you can categorize, so maybe you have a thing called a legal retention hold. So even though people think that they've deleted files, you may have a legal requirement to store those files for a period of time. So while the files will appear to be deleted to the end users or the people who deleted the file still exists for that legal retention hold. We also have time retention policies that you have in there. So we can set this on a per storage account, per container basis. And again, I'll do that demonstration for you when we do the demonstration at the end of this unit. Today, we're focusing in on Azure architecture, and we're going to focus in on a file type called Azure Files. So let's get in it. In previous units, we've talked about the different types of unstructured data that you have available to you. And as a category of unstructured data, Azure Files is different than blob storage. Blob storage is this new modern method to be able to store information and access it. It's typically accessed over an HTTP or an HTTPS connection. That's one of the big things that it's available through. When you take a look at Azure Files, this makes the file available through a thing called SMB, and you'll see that under the available protocols. That's the big distinction here. The benefit of Azure Files, it provides backwards compatibility to applications and your users because it allows them to use a thing called a UNC, or Universal Naming Convention, to map drives and mount them onto their systems so that they can consume them, whether it be your end users or your applications. Because there's some applications, especially containers, where you need to mount them into the service that is going to consume them. So an HTTP or an HTTP request doesn't work. So Azure Files provides that traditional backwards compatibility to a filing system if you need to be able to work with that. You'll also see that there's some different throughput versus different IOPS. And those are two different tiers. One has different read-write operations and performance that you're dealing with. Again, if you're a data storage person, you'll understand what those terms are. But if you're just an architect, it might be the question you want to ask of the end users is, how are these files going to be accessed, not only by a protocol perspective, but are you working for IOPS, read-write operations? Are you looking for throughput of that data itself? Because that might make the distinction of which one I want to use. But Azure File Shares, a great way to be able to create that backwards compatibility. You've seen that it replaces, some of those older traditional NAS or network access storage servers that you have and devices that provided these available on your network. There's also another version of file shares called NetApp file servers, and this provides for that high performance. So if you have massive throughput requirements that you're looking for, the NetApp file services is a enterprise class, you can read the slide as much as I can, that is going to really provide that capability for you. So it gives you some examples of HPC or high performance computing, Azure Batch, these very specialized workloads that need high throughput activity to the data on those storage disks. And that's what you're going to be able to get with a NetApp file system. This module specifically is going to be focusing on Azure architecture, and we're going to be looking at the different data solutions that we have, and specifically Azure Data Disk solutions that we can mount into our solution. So let's get into it. We've talked about storage accounts as a way to store different types of data. Specifically, we've been looking at unstructured data. And it builds a disk infrastructure for you to meet the different requirements of the storage account. You might want to be able to what is called an unmanaged disk, where you manage the disk's environments yourself, where you're going to build a disk infrastructure for you to deploy within your solution. You also have the capability of having unmanaged disks, which means it's being managed by Microsoft. And these are typically mounted within virtual machines as the operating drives within the VMs. And you're going to see that down at the bottom. So shared disks across multiple VMs is one of the reasons why you might have to have these disk options. We've talked briefly about the different types of drives. We've seen the infrastructure that Microsoft has across all of Azure. And we are constantly adding new infrastructure. But we've got literally some old hard drives or the HDDs, which are the old magnetic disks, and their throughput and their performance is maybe not the same as some of the new modern SSDs. And some of even the newer modern SSDs are even faster than the old ones. And so what you're looking at here is a full range of disks, and I'll be doing this in the demonstration, that allows you to configure a specific disk type and ranging from as little as 2,000 IOPS upwards of 160,000 IOPS using that ultra disk feature. So be careful. You want to make sure that you are matching the disk throughput and performance levels, which has cost, to the need to have that capacity requirement. You also want to be very careful. It's not highlighted in the materials as much, but if you attach these disks to virtual machines, which we have a module on, the virtual machine might also have a maximum throughput. So taking a high ultra disk throughput disk and attaching it to a low performing virtual machine is basically putting a throttle on that high performance disk. It would never be able to hit its full capacity. So as an architect, you really want to make sure that you're matching the capacity and throughput of all the units. It's the old adage of the weakest link in the chain. Yes, you've got some great 160,000 IOPS ultra disks, but attached to a low performance virtual machine, it becomes the low speed operator that will throttle the ultra disk use of that service. Today, we're going to be focusing in on Azure architecture and looking at storage security specifically. So let's get into it. When you take a look at storage, we've introduced a number of topics where we take a look at this thing called a storage account. You're seeing that in the middle center of the slide itself. There's a series of ways to protect a storage account at the storage account level and at each of the sub-levels below it within things like containers and within the objects themselves. The slide is pointing out a series of ways that you can protect the storage account other than other ways that we deal with in the topic specifically of the storage account. You're seeing that firewall policies, because storage accounts are usually existing within some kind of network access, a firewall policy can either grant or deny access to the storage account through the firewall policy. All data in a storage account is encrypted at rest, and it's going to be stored in an encrypted format using what is either a customer managed key or a Microsoft managed key to decrypt that information. When I do the demonstration, I'll show you how to switch back and forth, and I do want to make a call out now. By default, it is a Microsoft managed key, and that's there so we can help you. We talk about we run on trust. We don't get in and look at your encrypted data. That's not our job. It wouldn't be a very good business for us if customers knew that we were looking at their data. But there are regulatory requirements that some companies say, I can't have anybody else other than our authorized people looking at this data. And so they've asked for that feature, so we've given the ability to run customer managed keys. And that way, you and you alone are the only people ever possible to decrypt that data. Well, that's great. It's secure. But if you ever lose those keys, you can't come to us. We don't have any way to be what's called a key recovery agent to help you gain access to that data. There is no way for us to be able to help you with that. So you're going to want to follow the recommended standards that if you use customer managed keys, and it actually says when you switch to it, that you want to store those keys in a thing called Key Vault, not covered in this topic. So I just want to make that a special call out, especially from an architect's perspective. Another way that you can secure access to the storage account is to use what are called service endpoints and private endpoints. These are covered in the networking module as a way to secure public access to those storage accounts by creating what's called a service endpoint or private endpoint. I'm not going to go that much into it here, but these are all additional ways to secure the information in the storage account from an access perspective. Within the storage account themselves, we have ways to protect the data, the actual blobs that are stored in there, using RBAC rules and things called SAS tokens. They're not called out here, but they are called out in the section where we covered those specific objects. So we've now taken a look at the various types of storage that fell into that category of unstructured data. These are going to be your blobs and files. Now let's go into a demonstration. And what I want to point out as I go into the demonstration, I'll stop in the creation and show you the various types that you can create, whether it be LRS, ZRS, GZRS. I'll show those to you, but we will create one of them, and then we'll actually play with the files from a security perspective and how you can manage the different types of access. So let's get into that demonstration. While I'm creating a storage account from the graphical user interface, remember there's a variety of different ways to create them, and Microsoft's recommendation is to use a template. As with most objects, you're going to need a subscription, you're going to need a resource group in which it can exist in, this storage account name. Now this name must be globally unique because it will be appended to a URL name that needs to be publicly available. Know that at the time of this recording, not all resources are available in all regions, and by that I mean specifically the replication types that are available. Looking at US East, which is our largest region, you'll notice that it has a wide variety of the replication type. We have locally redundant, geo-redundant, zone-redundant, and geo-zone redundant. And the two geo options have the ability to make it read accessible. If I were to select another region, that will not have all these available at the time of this recording. Plan is to make them available everywhere. For example, if I go to Canada East, you'll notice that the replication types are only locally redundant and geo-redundant. I do not have the zone redundancies, both the zone redundant locally and geo-zone redundant. For the vast majority of your storage requirements, a standard storage account from a performance level is going to give you the most flexibility. If you need some high throughput requirements, selecting a premium storage account will now allow access to much faster disks, but you're going to lose some of the geo-redundant capability. And you'll see that the redundancy now only becomes locally redundant or zone redundant. I no longer get the two geo-redundant storage capabilities. I'll switch back to standard. Taking a quick tour of some of the other features of the storage account, we can get access to the types of storage. We mentioned that within a storage account, you can have blob storage, you can have Azure file shares. You can also switch this to a hierarchical namespace, which makes this available for Azure Data Lake storage. Looking at networking capabilities, we can give public access to this, or I can disable this. I'll do a review of this when I go into a storage account. From a data protection, you can now have the soft delete of the blobs, or at the container levels, all of these can be enabled. We talked about encryption, and the default is to use Microsoft Managed Keys, but if you have a security requirement that requires you and you alone to have access to this information, especially for key recovery agents, you can have customer managed keys. And note that it does recommend that you store those keys in Key Vault, because if you were to lose access to any of your keys, Microsoft would not have any ability to assist you in the recovery of that information. Once you've created the storage account, you can see that all those features that we set up, the location that it was configured in, the performance type, the redundancy that you've got configured, and the storage account type is available for you. You can see that it has been stored as a hot versus a cool storage, and I'll show you where you can change some or most of these values. Under the settings capability for configuration, you can see that if you had a standard account, you can change it to a premium, but it is a one-way switch. And here's that hot versus cool capability to change the default value. Each object that exists within the storage account can have its own attribute set, but this is where you can change the default value, which will be inherited. Working with data storage, I can take a look at the specific types of storage we talked about, the blob storage in containers. We also have our file shares. It's in here that I can actually build new containers to access the objects. Under data management, I can change the redundancy types if I wanted, from locally redundant to the ones that are available in the region that I've deployed to. I can manage the data protection values that we originally set up for the soft delete capabilities, as well as working with the lifecycle management to create an automated process to move files from hot to cool to cold through to archive, as discussed with lifecycle management from the lesson. Let's return back to the lesson. Welcome back from the demo. Hopefully that was interesting for you and you saw some of the options that are available for you. And remember, I want to stress that, some people generalize that, the different types of redundancy that you have. And we talked about hot versus cool and some of the capabilities along the way. You really want to take a look at the speed and performance and the access levels, because it can be a nuance, because you're billed for not just the storage of the data, which is relatively inexpensive, but if you pick a cheaper storage tier, but you access that data a lot, it can have a big impact on your cost overall. So make sure that you're looking at the totality as we discussed in this lesson, to make sure you're picking the right type of storage you're dealing with. We saw that from an unstructured data perspective, that we had a variety from a backwards compatibility using Azure file shares and its capability to have that SMB or server message block access. We saw the modern way of storing those same files in a blob storage. We then took a look at the different redundancy types that we had available for us, and we took a look at some of the ways that you could build your storage disks available for you from your VM perspective, would it be the term was managed or unmanaged disks that we're dealing with. And we saw various ways to secure that information, whether it be using some of the encryption capabilities, whether it be using file access shares that you're dealing with, or if it's getting into traditional RBAC, the role-based access control, or are you going to use those SAS or shared access signature tokens? So a wide variety of options that, as an architect, it's your job to figure out what is going to be the best solution in the mix of the right type of storage with the right type of access with the right type of security to meet your needs. So with that, thanks very much for joining me in this lesson. I look forward to seeing you in the next one.